Hi, everybody. This is section 10.4, polar coordinates and polar graphs. Let's take a look. All right, when we're looking at polar coordinates, if you remember, we did this in pre-cal. The first part of a polar coordinate is the distance you are from the center. That's the R. And then this is the angle you are from the x-axis. So this particular spot, if you look at it, the angle is pi over 3. Pi over 3. And R in this case is 2. So this is the polar coordinates of that dot. Here we have an angle. If we go clockwise, the angle is negative. If we go counterclockwise, the angle is positive. So this is a negative pi over 6. And the R is right here. Looks like it's 3. And finally, on this one, remember, going all the way around is 2 pi. This is 11 pi over 6, almost 2 pi. It goes right here, from here to here, 11 pi over 6. That's 11 pi over 6. And the R is 3. Now, I'm not exactly sure. There's the 11 pi over 6, and there's the 3. They have a negative in there. I think they put that in there by accident, so it was left over from over here. Because negative 11 pi over 6 would be somewhere over here. So I think there's a slight error there. All right, let's move on. Some trig functions that we need to just refresh ourselves with. If we call this theta, the tangent of theta, remember from trig, the tangent of theta is opposite over adjacent. So tangent of theta is opposite y over adjacent x. Tangent theta is y over x. Cosine theta is opposite over hypotenuse. No, it's adjacent over hypotenuse. That's it. Cosine theta is adjacent over hypotenuse, x over r. And finally, sine theta is opposite over hypotenuse, y over r, y over r. So these are just basic trig functions we need to know. And these are our formulas. Change them from polar to rectangular and rectangular coordinates to polar. So we might want to write these down. Okay. All right. Polar to rectangular. So we want to change these to rectangular coordinates. Here's our polar equivalent. I mean, we could draw the picture of this. The angle is pi, which is all the way around. And then we go to 2, 1, 2. So it should be a dot right there. Don't forget how to convert polar to rectangular. See, this is polar, and we have to change it to rectangular. X equals r cosine theta. And don't forget about y equals r cosine theta. And once again, r is 2. This is r. And cosine theta, theta is pi. R is 2 cosine. Oh, sorry, this is sine. It's always good to have those formulas in front of you. R sine of pi. Okay, grabbing my unit circle. The cosine of pi is -1. And the sine of pi is 0. So the coordinate is -2, 0. That's exactly what the coordinate looks like. -2, 0. All right, the next one. Here's our r, and here's our theta. Once again, r and theta for x, and r and theta for y. And cosine of pi over 6 is the square root of 3 over 2. R is the square root of 3. Square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. So x part is 3 over 2. Sine of pi over 6 on my unit circle, sine of pi over 6 is 1/2. Square root of 3 times 1/2 is square root of 3 over 2. So our coordinate is 3 over 2 for the x and square root of 3 over 2 for the y. All you're doing is plugging it in. It's really not that bad. All right, let's take a look at these 3 graphs here. And we're going to convert them to rectangular equations. If we go to our formula, r equals 2. So for r equals 2, if you look at the graph, r equals 2, r is 2, the radius is 2, no matter where you look at it. So this is just a graph of a circle. And remember, our formula for a circle is this. R is 2, so this is going to be the rectangular equation for the circle. And let's take a look at that. There's the circle with r equals 2. And r is 2, no matter where we have it. It's a circle with radius 2. And so there's our equation. Now the next one, if we look back up, the next one is just theta equals pi over 3. Well, the angle pi over 3 is right here. So if we look at that, it's just a straight line on pi over 3. But we want the rectangular equivalent. And if we go to polar to rectangular or rectangular to polar, we have theta equals pi over 2. We can actually do this tangent both sides. Tangent theta equals tangent pi over 3. So whatever you do to one side, you can do to the other. And the tangent of pi over 3, I'm going to pi over 3. Don't forget, it's the sine of pi over 3, tangent over the cosine of pi over 3. The sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1/2. So the tangent of theta equals this divided by 1/2 times what it just ends up being the square root of 3. So how they got this answer, once again, they took the tangent of both sides. We had theta equals pi over 3. They took the tangent of both sides. Well, in reality, they didn't take the tangent of both sides. They looked at the formula. The formula from rectangular to polar you can do is tangent theta equals y over x. This is the formula they used. Tangent of theta equals y over x. And we know theta is pi over 3. And we already said the tangent of pi over 3 is the square root of 3. See, now we have x's and y's. If we just take the x to the other side by multiplying both sides by x, we end up with square root of 3 times x equals y. And there, that's an equation having x and y in the equation. That's what we want for a rectangular equation. So all we did was take the rectangular polar equation tangent theta equals y over x and plug in the theta. The theta was, we already said theta was pi over 3. And the tangent of pi over 3 is square root of 3. And we have one more. R secant theta. Well, we can also go to the formulas and show that secant is 1 over cosine. So I can change this to R equals 1 over cosine theta. See, these are the same thing. Secant is 1 over cosine theta. Now, if I multiply both sides by cosine theta, multiply this side by cosine theta, multiply this side by cosine theta, these cancel out. And I'm left with this. R cosine theta equals 1. Well, R cosine theta from polar to rectangular coordinates changes to x if you look at our formula. So our rectangular equation is just x equals 1. It's a line. X equals 1 is a vertical line going through 1. All righty. All right, let's do slopes of tangent lines. We should write down this formula. It's the same thing from parametric equations, kind of. Dy dx, take the derivative of y with respect to theta, take the derivative of x with respect to theta, and they show, use these formulas, f theta cosine theta plus the derivative of f sine theta and negative f theta sine theta plus the derivative of theta cosine theta. This is a good formula to have written down, and I think they have it on the next slide. There it is. All righty, that's theorem 10 and 11. A couple of things you need to know. When you're looking for the horizontal tangent line, it's going to be dy d theta. So these are things you have to know. When we're dealing with vertical tangent lines, you're going to have to look at dx d theta. And if you notice, you can't have dx d theta and dy d theta both equal to 0 at the same time. You can't have them both equal to 0, their slopes equal to 0. And it says no conclusion can be drawn about those tangent lines. You can't have them at the same time equal to 0. How can you have a horizontal tangent line and a vertical tangent line? Oh, you actually can if you're looking at circular points on a circle. So here, example 5 says, find the horizontal and tangent lines of r sine theta. So once again, horizontal tangent lines are dy d theta. So we know r equals x equals r cosine theta. If you look here, this is the let's just do one at a time. If you look here, r in the equation, r equals sine theta. So we are going to replace this r with sine theta. That's what they did here. Cosine theta is the same, but they replaced the r with the sine theta. So now my x equals sine theta cosine theta. Here, they did the same thing, r equals sine theta. So y equals, I'm going to leave it as sine theta times sine theta. And we're to find the horizontal tangent lines, you have to take the derivative of this, and you have to use product rule, right? Okay, so let's use the product rule. You can call this U and this is V or F and G or however you want to do it. Is it U V prime plus V prime U? U is sine theta. The derivative of cosine is negative sine theta plus V prime. V is cosine, so V prime is sine theta, and U is sine theta. Okay, let's try this again. So this is what we got for x, sine theta, cosine theta. And if we take the derivative of x, we can use the product rule, uv. So u, derivative of cosine is negative sine. Then we have du, which is cosine theta, and times the cosine of theta. So this becomes negative sine squared theta plus cosine squared theta. And if you go to our trig formula sheet, there's a double angle identity where we have a negative sine squared theta and a positive cosine squared theta. This turns to, it's a double angle cosine of 2 theta. So this is the answer to the derivative of x cosine 2 theta. And to find out where, in this case, vertical tangent line, x is the vertical tangent line, you make it equal to 0 and find all the things that make cosine 2 theta equal to 0. In other words, where does cosine theta equal to 0? And it looks like pi over 2 and 3 pi over 2. Now this bottom one, let's take the derivative of this. Making it UV, U. Derivative of V is cosine theta. Same here, du is cosine theta, sine theta. And we have the same thing twice. So this is 2 times sine theta, cosine theta. And there is a trig identity in that double angle formula that does the same thing. This changes to sine 2 theta, right? Yeah, sine 2 theta. And we set sine 2 theta equal to 0 and find out where sine of theta equals 0. Looks like at 0 and pi. So now we can take a look at the next slide. You see on the first one, cosine 2 theta equals 0. They should give us there. Oh, cosine 2 theta equals 0 is pi over 4 and 3 pi over 4. That brings up a good point. We know, if we look here, we know the angle that we can put in here. The only place that cosine equals 0 is at pi over 2 and 3 pi over 2. But if we have to multiply it by 2 to get that, what number do I, 2 theta equals pi over 2. How do I get theta? Divide both sides by 2 or multiply both sides by 1/2, and theta equals pi over 4. You see, if I multiply both sides by 1/2, I get theta equals pi over 4. And then the other one is 3 pi over 4. So we know at pi over 2 is the one that will make it equal to 0 and 3 pi over 2. But if we divide by 1/2 or multiply by 1/2 on both sides, these are what we get. On the second one, same thing we already said. 0 and pi. Sine 2 theta equals 0. And we already said 0 works for this, and pi. If I did the same thing, 2 theta equals pi. If I divide by 2 here, divide by 2, then theta equals pi over 2. If I divide by 2 here, then theta equals 0. So we can see the horizontal tangent lines. And the vertical tangent lines. Okay. And we have, I think, one more problem to do here. Oh, I guess not. Let's go to the homework. Okay, so in the homework, we want to plot this polar coordinate 5 pi over 4. This is 4 pi over 4. So 5 pi over 4 should be somewhere over here at 7, 6, 7. So it should be somewhere here. Let's see if we can find any of the graphs with a dot in that third quadrant. And I see it right here. Once again, that line right there is 5 pi over 4. So that looks like the correct graph. Now we do want to change it to rectangular coordinates. And our rectangular coordinates for this are x equals r cosine theta and y equals r sine theta. R is 7 and cosine of 5 pi over 4, y equals 7 and sine of 5 pi over 4. So let me go in that quadrant, and cosine and sine of 5 pi over 4 are both negative square root of 2 over 2. So there's my x coordinate. And there's my y coordinate. And that's what we got. So we're just using the formulas to plug this stuff in. Let's try another one. The rectangular coordinates are given. Plot the point, well, 5, 0. All I gotta do is find 5, 0. There we go, right here. And there's a rectangular coordinate, 5, 0. Okay, do we want to change it? Then the rectangular coordinates of a point are given. Plot the points. Don't they want us to change it? Oh, find the 2 sets of polar coordinates. So yes, they want us to find the 2 sets of polar coordinates. So to find the two sets of polar coordinates, once again, here's our 5 and 0. This is our x and this is our y. Polar coordinates are y equals r sine theta, and x equals r cosine theta. So I'm going to, let me delete those. We don't need these, I don't believe. We are going to switch from rectangular to polar. Rectangular to polar. And rectangular to polar, we should be using tangent theta equals y over x. So the tangent of theta equals 0 over 5 y over x. So the tangent of theta equals 0. And the tangent of theta equals 0. Tangent of theta equals 0, so theta equals 0 also. Theta equals 0. Right, tangent of theta equals 0. That's sine over cosine, and that would be at degree 0. Or degree pi, 0 or pi, I guess. We also have another formula. R squared equals x squared plus y squared. R squared equals x is 5 squared plus 0 squared. R squared equals 25, so R equals plus or minus 5. So we have an R plus or minus 5 and a theta. And if we go down, we should see it if it lets me go down. My God. So we have plus or minus 5. If we have the 5 here, we have 0. And you can also go an angle of pi with a negative 5. Kind of cool. So those are our two coordinates. And I wanted to do question 13. Wherever that is down here. Here we go. Find the points of horizontal tangency to the polar curve. Now, if you remember, vertical tangency was taking the derivative of dx. Horizontal tangency is dy. So here's our R. And I'm looking at my formula for dy. dy d theta equals f theta cosine theta plus f prime theta sine theta. Here's our function. Two cosecant theta plus 3 times the cosine of theta plus the derivative of this Okay, so when I find the derivative of this here, you can go to your calculus derivative sheet and look up the derivative of cosecant. The derivative of cosecant is would be then 2, where is it at? Right there. It's a negative. Let me just show you the derivative. Here's cosecant. Let's say if f is cosecant, theta, then the derivative of f is negative cosecant theta. Hang on, my pen's not working. Cotangent theta. So this is the derivative. Negative cosecant theta cotangent. That's a cotangent theta. That's the derivative. So what we get for the derivative here is the negative 2 cosecant theta cotangent theta cotangent theta. And then from the formula, the sine theta is in there also. All right, so I'm going to distribute here and I get 2 cosecant theta times cosine theta plus 3 cosine theta minus 2 cosecant theta sine theta cotangent theta. Oh Lord, it's becoming a mess. I'm gonna have to clean this up somehow so I can see it. Let me clean this up a little bit. It's a little bit of a mess. So we ended up with 2 cosecant theta times cosine theta plus 3 cosine theta minus 2 cosecant theta sine theta cotangent theta. All right, so cosecant is 1 over sine. So this can change to 1 over sine. So cosine over sine becomes cotangent. So this is 2 cotangent theta plus 3 cosine theta. And this becomes the same thing. And I see an error here. This, oh no, I put the sign here. No, this is fine. That cotangent theta is supposed to stay there because this sign went here, this went there. Now, cosecant theta and sine theta, cosecant is 1 over sine. So these two end up canceling out and we're just left with the -2 cotangent theta. These two, the cosecant and sine, will cancel each other out. Then we also see 2 cotangent theta and -2 cotangent theta cancel each other out. And we're just left with 3 cosine theta. So the derivative of y just ends up with 3 cosine theta. That's what I ended up with, 3 cosine theta. And to find, once again, to find the horizontal tangency, set it equal to 0, cosine theta equals 0. And where is a cosine theta equal to 0 on my unit circle? At pi over 2 and 3 pi over 2. So at pi over 2 and 3 pi over 2, that's where we have the zeros. Pi over 2 and 3 pi over 2. Now to get the 5 and the 1, we have to. Okay, so to get the 5 part here, that's the r, don't forget. R equals 2 cosecant, and we're talking about the first one, pi over 2, cosecant of pi over 2 plus 3. And the cosecant of pi over 2, first of all, cosecant is 1 over sine. If sine is 1, 1 over 1 is still 1. So we end up with this equaling 1. So r equals 2 plus 3, r equals 5. In the next one, was 2 cosecant theta plus 3. When cosecant theta equals 3 pi over 2, this ends up equaling a -1. So 2 times -1 is -2 plus 3, which equals 1. So that's how we got that r. All right, I hope this helped. I'm going to post the homework for you and this video. Guys, have a good day and let me know if you need anything.